Now let's discuss about force. So what do we understand by the word force? The simplest meaning of force is either a push or a pull. Whether you are pushing something or if you are pulling something, it is termed as force, right? And in SI unit, force is measured with the help of newtons, right? In SI unit, the force is measured with newtons, and the newton is termed after a scientist, Sir Isaac Newton. So 1 Newton is equivalent to 1 kg meter per second square of force. We must remember this because this is most important terminology associated with force, correct? Now, if we talk about CGS unit, in terms of CGS, force is defined by dynes, and 1 dyne is equivalent to 1 gram centimeter per second square. So basically, when we are defining force, it is either a push or a pull, right? It is associated with all kind of object. If we are pushing something or if we are pulling something, it is termed as force. This is the most simplest form of force. So here you can see two examples. One is a block. There are two people. One is pulling it. One is trying to pull the block and another person is trying to push the block. In both the cases, there is some force associated with it. Either you are going to pull it or you are going to push it. You will encounter some kind of force. The second example is this ball, right? When you are going to kick the ball, you will require some amount of force to kick that particular ball. Then and then only that ball will have some motion, right? So this is all about the simplest form of force. Now let us see what are the natural forces, right? What are the forces which are available with us in the universe? What are the natural forces? So when we talk about forces of nature, there are 4 various forces. First one is gravitational force. Second one is electromagnetism force or electromagnetic force. Third one is weak nuclear force, and the fourth one is strong nuclear force. These are also termed as the 4 fundamental forces. Always remember that there are many type of forces, but these 4 forces are termed as fundamental forces, right? What are those? Gravitational force, electromagnetic force, weak nuclear force, and the strong nuclear force. These 4 forces are termed as 4 forces of nature or fundamental forces. Clear? Now one by one we will see how they differ with each other. So coming first to gravitational force. We all are quite familiar with how apple fall on a person's head and how we termed it as a gravitational force, right? But what exactly a gravitational force is? The gravitational force is a force between any two bodies due to their mass. Again I am repeating, force acting between any two bodies due to their mass is termed as gravitational force. The gravitational force is responsible for keeping you intact or attached to the surface of earth, to the floor at this moment. Clear? The earth mass is pulling us downward and it's towards its center, and our mass is attracting earth upward toward us. Clear? So these both are balancing each other. That's why we are at a static position, or we are at some static condition. Clear? What happens if gravitational force is absent? If suppose we do not have gravitational force acting on Earth, then what will happen? In that particular case, we will be freely floating throughout the Earth. Clear? This is only and only due to gravitational force that we are intact or attached to the surface of Earth. We are able to walk, we are able to run, we are able to travel. If gravitational force is absent, we will start floating on the surface. Clear? So gravitational force is basically the force acting between two bodies due to their mass, right? Now moving ahead to the second force. So the second force is electromagnetic force. So as the name suggests, electromagnetic. There is some electricity, there is some magnetic properties, right? So this term is made up of two different terms, electro and magnetic, or electro and magnet. Clear? So the electromagnetic force is basically responsible for attraction and repulsion of electric charges. Again I am repeating, electromagnetic force is responsible for attraction and repulsion of electric charges, and is also responsible for magnetic forces. Clear? So it is electromagnetic force due to which there is attraction and repulsion between charges which are present in our universe, right? So generating light is one of the example of electromagnetic force. When a negative electron interact with a positive proton, the electromagnetic force adds energy to the electron for generating a photon, and this photon is nothing but the light which we are utilizing or which we are enjoying. Clear? Moving ahead to the next one, which is strong nuclear force. So what do we mean by a strong nuclear force? The strong nuclear force is the force that holds together proton and neutron in the atomic nucleus and overpowers the electromagnetic mutual repulsion of the nuclear proton, right? It is responsible for nuclear fusion, which is the process that causes sun to shine and gives the sunlight to entire universe. Clear? So strong nuclear force is basically a force which keeps neutron and proton attached to each other, right? It is keeping neutron and proton attached to each other, or it holds proton and neutron together in some atomic nucleus, and due to this we are able to get the sunlight. Clear? As you can see here, this is the force which will be able to keep them together or intact in this particular structure, and due to this there will be a nuclear fusion. Nuclear fusion means once they are attached with each other, the large amount of energy is created, and that energy is then reflected in terms of light. Then comes a weak nuclear force. So what do we mean by a weak nuclear force? The weak nuclear force is responsible for the process of decay, right? Weak nuclear force is responsible for the process of decay, in which neutron in atomic nucleus decay into proton and electron escape from the atom. This is known as weak nuclear force. So what happened in weak nuclear force? Whatever atom was present, it will start decaying in the form of neutron and proton. Clear? and that neutron, proton and electron will get decayed and it will be in different form. So this is a weak nuclear force.